Welcome everyone, and thank you for joining us for today's live Select demonstration. My name is Robin. I'm the Marketing Communications Coordinator at Biotage. Now, I'd like to introduce our presenter, Austin Schlirf. Austin is an application scientist at Biotage. He has a background in biomedical engineering and has conducted research across a variety of biomaterial applications, ranging from synthetic bio-inspired hydrogels to mucin glycopeptide mimetics. Today, Austin supports our North American installed base for small molecule and peptide research and is based in our Charlotte, North Carolina applications laboratory. Also joining us today is Simone Cardy-Stribling. Simone is an application scientist specializing in peptide and small molecule synthesis, purification, and chromatography workflows. Simone has earned her PhD in organic chemistry from the University of Houston and supports customer training, technical applications, and workflow development across Biotage platforms. Simone is also based in our Charlotte application lab and will be assisting with the poll questions and helping manage audience questions throughout today's sessions. With that, I'd like to turn things over to Austin to begin today's live demonstration. Austin, it's all yours.
Thanks, Robin. And just another kind of couple of notes. I have a couple of views for you guys here. I do have a system view, and you should also see a user interface view just to make it a little bit more clear what we're doing on screen up here. So if at any time you can't see it, please let Simone or Robin know, and we'll make sure that we make sure you can see everything. What I'll start off with today is going to be the hardware of the system, get a little landscape of what we have going on from a system perspective, and then we'll move into programming the system, operating the system, and show you a live run today. So again, ask any questions, happy to answer any of those during the presentation. What we'll start off with is what is the Selekt? The Selekt is a 2-channel 4-solvent automated flash system designed to completely change your workflow, especially if you're coming from a manual flash apparatus. Up here at the top, I'll just give you kind of again, a landscape. We've got our 4 solvents. Today I'll be mostly working in normal phase, but you can set the system up to work in both normal and reverse phase in a single system. So it saves benchtop space. You don't have to have multiple systems for multiple different phases of chromatography. On top of our bottles, we do have our liquid level sensing module. This module is designed to track solvent and track solvent consumption before and after runs. This allows us to make sure that when we start a run, we're not going to run out of anything. And so as the user yourself, you don't want to start a run, come back later and find out that everything was for nothing. So protects you. It also allows us to keep track of all the waste generation and make sure that our waste is not going to overflow, and also how much we're actually creating. So we can kind of track and monitor our complete workflow in that sense. Down below the solvents is our main user interface. So this is where we do all of our programming. It's the brains of the operation. So we'll show you that a little bit later. Below that, we do have our fraction collection racks. Our fraction collector has RFID racks that are designed to track what type of fraction sizes you're using, where your fractions are going, and what is in each of those fractions. And those can be linked to reports at the end of runs, so you can easily find your sample later. Over on the left-hand side, which you can't see, is going to be our UV flow cell. So that is in tandem with a PDA detector that can scan wavelengths anywhere from the low UV nanometer range, 198, all the way up into our visible spectrum up to 810 nanometers. So it gives you a plethora range of access to be able to see your molecules and also never miss a molecule. Over here on the right-hand side is our evaporative light scattering detector. This is a completely modular unit. You don't necessarily have to get it when you get the system, but it is really useful as a universal detector. It functions simply by creating particles of your sample, sampling that from the main flow, and then scattering light and detecting that scattering to say, do we have a molecule or do we just have solvent? So it allows us to, again, find molecules that maybe don't have a UV or visible wavelength chromophore. So with kind of our hardware overview, I do want to open it up to you guys to help tailor today's kind of talk. with our first poll question. I am curious what you guys are most interested in to kind of learn from today. So I'll turn it over to Simone for that first poll question.
Our first poll question today is, what is your biggest challenge in purification today? All right, time to release our answers. Our most popular answer is improving reproducibility.
Wonderful, wonderful. Great. A different answer from this morning. People are interested in moving from TLC to actual flash run. So I'll kind of focus a little bit on how to make sure that we're being more reproducible, especially column to column or run to run. So I'm going to move over to the software portion of this so I can kind of walk you guys through. So blow that up so you guys can see this a little bit more. And I'll walk you through our user interface. So just kind of walk you around this user interface. We'll start down here on the bottom left-hand side with our information. So under this information tab, this is going to track your user logins or users that you have on the system. So one way to improve reproducibility is to be able to find your work. So being able to, input that information based on, who's doing the run of that day, or even to control what methods that you're actually using. So with our latest software, you're actually able to program specific methods for either specific projects or for specific columns. So our columns do come especially with a QR code, and those QR codes are again linked to the column specifications that you have. So if you have a common run that you're doing on a daily basis, it'll automatically populate that onto your run. Lastly, obviously run name. This is where you can capture based on date or project information. Just allows you to name your sample here. For the column information, so like I said, all of our columns do have a QR code, which will automatically populate this information for you. So you don't have to worry about what is my ideal flow rate for the columns that I'm utilizing that day. So all of this information gets populated, and it keeps track of number of runs for columns if you're running reverse phase, and also all the other kind of basic information you might want. One thing that I really like about the Selekt system is that you can actually type a sample mass in here to help you determine what column size or type that you want to work with. So say I'm working with a gram of material for the day and I hit OK. It's going to give you a color indication of, hey, is the column that you've currently chosen good based on the load parameters, the basic load parameters of that column. For here, a gram on a 5 gram column is about, what is that, 20% load, pretty high for your standard columns. But if we hit this drop down menu, it'll give you everything in green. Will be a column that is applicable for this purification and give you an estimated load capacity. This is also organized by the most efficient column. So those of you who are looking to have shorter columns or utilize less solvent, those will be populated at the top for you. So for in this instance, we're recommending starting with a 10 gram column. Today, we're only going to do about 50 megs, so perfect for our 5 gram column. Moving over to the right here is our collection parameters. So like I said before, we have several ways of actually looking at molecules coming through the system. So our Lambda All feature is part of our Spectra software package, so that it allows you to not only look at different wavelength ranges, but also to analyze those later in the run or during your run. So here we can set collection, hide, or show, depending on how we want to watch the data as it's coming off the system. And again, we can change those wavelengths to match the UV profile of our compound, especially if we're looking at different ranges or we want to increase sensitivity. You can look at specific wavelengths. I typically will set these to some general wavelengths that I know are pretty high absorbing nanometers for common molecules, just to make sure that I'm not missing anything. We're not going to be using the DLSD today, but if you guys are interested in more, please let us know, and we can maybe set up a more personalized demo for you. Some other last kind of additional options that we have, if you guys are concerned about losing samples, you can always collect all. And this will collect all of the fractions that are coming off the system. So if there is a chance that you don't know the UV absorption, or you think that your molecule isn't going to be seen by the system, you can always hit that and collect everything so we don't lose our sample of interest. UV baseline correction, I always try to keep that on, making sure that if there are any solvent effects for my UV absorption, that's going to get subtracted out of the signal. A couple of our new features, P-Cold is going to hold an isocratic solvent condition after it detects a peak, which can help sometimes pull peaks apart. You can also utilize initial waste. If you know that the earlier fractions that are coming off the system are you're not going to want to collect them at all, even if they have some sort of signal, then we can send those directly to waste, and it saves on fraction collection and kind of workup later on. So with that, we can go ahead and start talking about how to design a gradients, but I am curious, what type of chromatography is everyone doing? So I'll turn it over to Simone for our second poll question of the day.
Our second question today is, how many compounds do you purify per day?
Perfect.
Once again, 1 to 3 is our most popular answer.
Okay, so a little bit similar to what we had this morning. So hopefully we can show you how to at least get some chromatography done a little bit quicker, so you can maybe pump out some more molecules. For the actually designing a gradient, I'm going to move back to my laptop over here using our Selekt remote software. So I'm going to kind of walk through the gradient portion of this. So there's a couple of ways that you can create gradients. There are several different options. We can do linear gradients, we can do focus gradients, and we can do step gradients. So for instance, if I want to change what's on the screen here, I would simply click or touch my screen and drag it around to the conditions that I want. You can also utilize this tabular form over here on the right-hand side. So we can change this to different parameters simply by using this tabular form. And maybe we want to do half a column volume at the end for whatever reason. And the one that I really like the most is utilizing our TLC to gradient feature. So this basically takes TLC information and creates a gradient designed to elute your product basically inside in the middle of this. So I'm going to kind of switch over to our system here. I do have a TLC plate prepared for today with a couple of spots. And if I move over to my system and I line up, if I line up my TLC plate to the starting conditions and the solvent front, I can very quickly pop out a gradient, again, designed to elute. Touching the screen in too many places. Designed to elute my compound. So this is going to be a linear gradient to start. I can also utilize this TLC to gradient feature to create step gradients. So I can just simply add a secondary plate, and we can create a step gradient in a similar manner. We're not going to do that today. Perfect. So then once I have my gradient, I am ready to equilibrate my column. So again, all of our columns do have that QR code on them. I'm simply going to scan it, and it's going to pop up that information. So now that I also have and it's also going to ask for my default method. We're not going to use that for today. So if I do have my TLC information, it'll also give us better selection parameters from our column. So now if I type in a gram of material, it'll give us better options based on those RF values. 100 megs a gram. So again, our 5-gram column is no longer great, but now it's telling me that a 25-gram column would be better based on that TLC information. So we do try to aim for our spots to be anywhere from 0.1 to 0.4 RF value. This is typically going to give you the best separation. But for this instance, it's saying that our 25-gram column would be great for 1 gram of material. But again, we're on the small scale, should be perfectly fine for this column size. So I've got my column parameters. I've got the column that I'm going to be using today. Today, I'm going to be using our sealed sphere HC column, typically designed for liquid loading. So for all of our columns, before you hit play, you're going to connect it to our solvent system. In channel 1. Secure our column, and then go ahead and hit the play button. So now the system is going to automatically equilibrate the column based on the column parameters that we've told it. One benefit of utilizing the Selekt is that this system has a higher pressure capability, so we're able to also equilibrate our columns at pressure and a lot faster. So that is something proprietary to Biotage. And what this does is it allows us to use less solvent for equilibration and less column volumes for that equilibration, so it gets to a ready state much quicker than other systems. So obviously, already equilibrated while I'm talking. Now it's going to ask me to load my sample. And there are a couple of ways that we can load the sample. So like I said, my sealed columns are designed for liquid loading, so I can just use a simple syringe. But we also have our duo style high capacity columns and our other media flavors that are designed for a lot of different purposes, for dry loading or loading directly onto the column. So all I would have to do that is take the top off. So these are designed to be unscrewed. And I can pop out the diffuser that's designed if I wanted to use for liquid loading. And all we have on the inside is just a simple frit. So I can liquid load directly onto that frit. If I have my compound as a solid, I could always, or mixed around with some dry load media, I can always sprinkle that on top, load it and repack the column. I can also utilize what we use is called a samplet. So you can, this is just a dried media, comes in different flavors. We have diatomaceous earth, we've got amine functionalized, and we have our basic silica. And so you would just put your sample on top of this samplet, allow it to dry, so it's going to remove those solvent effects from the column and from your chromatography, which can help improve purification. Then I would simply place my samplet into my duo columns cap, tighten it down, load it back onto my solvent, and hit play and allow it to run. We can also utilize our dry loading vessels. So these come either empty or pre-filled, again, with your media of your choice. And we can load our sample on here, allow it to dry, use our plunger system. This is definitely useful, especially when you're using larger amounts of silica. Attach this up, place this on top of the column, and then hit play and allow our sample to run. So again, a couple of different options for loading. Ideally, you have your sample that is highly soluble in your loading solvent, and that is also a weak solvent. So it's asking me to load it. So I'm going to go ahead and take the top off my column, grab my syringe, and load my sample. So today I'm just doing isomer mix of 2,3,4 nitroaniline. If you guys ever want to do this at home, and basically demonstrate, what kind of separations we get from compounds that look fairly similar. So our high capacity media is our smallest particle size, so it is going to give us the best resolution. And I typically tell customers, when you're loading, start on the small side, especially when you're doing development work. This is going to save sample and save solvent, especially when we're working on small scale. And that way, once you've gotten a run that looks good, then you can scale that up to the scale of your choice, especially when you want to do grams of purification. So once I load my sample, I'm going to go ahead and hit play. Now the system is going to go through a couple of things. It's going to, one, zero your detector, and then it's going to start subtracting whatever your gradient run is from the UV absorption spectrum. So it's going to run that gradient through the detector, subtract that background signal so that we have a nice flat background. And while it does that, I'm going to open up maybe a chance to take a question from the audience, or maybe our next poll question, Simone.
Sure, we'll do our first viewer question. If I already have an analytical HPLC method, how quickly can I translate that into a flash purification method on the Selekt?
Sure. So I'm assuming you're doing reverse phase with HPLC. So we have a couple of different workflows that we use here at Biotage. So typically we're trying to identify where does that compound elute on an HPLC system. Or with an HPLC solvent system, and that gives us an idea where it's going to elute on flash. So the biggest thing that I like to say is that it's going to come out a little bit earlier. We get a little bit less retention comparatively to HPLCs. So keep that in mind when you're designing your ingredients. But I think that's probably one that I would maybe want to walk you through, but we do have a lot of literature on the Biotage website that can kind of walk you through some of this stuff. Cool. And so the gradient started. How about another question from the audience?
Our second viewer would like to know, what does the RFID rack actually do for me day to day?
Sure. So I guess, let me see if I can show you on the software over here while it's running. I'm just going to take control. load that. So one thing that I will do is, so these gray dots here is going to highlight runs that I did previously for our demonstration earlier today. So it's going to keep track of what's going on with the rack. You can set those racks up to do a single run, so kind of isolate samples that way. But what it does is it also tracks anything that has been run on the system. So you can see, I can see reports from earlier. And I can also go in and look at the runs that I've been doing, in the lab, and I can go back and find out where those. I can go and find, what rack I was using and where that fraction is. So if I wanted to click here, so it's tracking the rack ID and what fractions were which based on the purification that I was running. So that's how you can kind of keep an eye on where your samples are and what's going on. Great question. I think I've got one more before my first peak comes out, so I can take one more, Simone.
Our next viewer would like to know, if my compound elutes much earlier or later than expected, can I modify the gradient while the run is in progress?
Great question. Absolutely. So again, I'll walk over to my remote software over here. So if I did want to change the gradient, I can always come in and start moving things around. So I can grab that gradient, make it more aggressive, make it less aggressive. I can also come over here to the tabular portion and add in different steps. So maybe after I've done this flat isocratic hold, I now want to go up to, let's say, 100% over another 10 column volumes. Finish at 10%. So I can make these kinds of adjustments on the fly if I wanted to. So yes, you can make adjustments to the gradient as the run is proceeding. And perfect timing as my first fraction is coming out. So what you can see up here in the top right is an actual UV spectra of the compound itself. And we can actually, with the newest and latest software, analyze that peak based on what that UV spectrum is. So I'm simply clicking this button here, which is looks like a little graph. And now I can see the live readout of what my UV trace is. So if you know exactly what your compound is, UV spectra is, now you know, hey, this is my compound of interest. So if you wanted to end the run early, you can always press pause and abort. And now you've saved the entirety of your run and your solvent. But it kind of gives you an idea of what's going on as fractions are coming out. So here's our first peak, a very nice peak compared to my morning purification. Probably how I loaded it. And so, speaking on reproducibility, some of that has to come down to column construction and column quality. So here at Biotage, we do intend to give you the most reproducible columns and have the most reproducible packing. But some of that is also reliant on keeping the system clean. So one thing you'll see at the end of this, and something that I didn't talk about with the hardware at the beginning, is all of our mechanical bits, all of our tubing, even our UV flow cell is accessible to the customer. So keeping the system running as expected, making sure that we have our lines cleaned, or even able to be flushed without having to completely take apart the system, is kind of a feature of making sure that that your runs are going to work from run to run. So easy maintenance and high quality and quality columns are going to lead to that reproducibility. But also making sure that we have equilibration that's the same every single time that you run a sample. So all these can kind of play a role in that reproducibility. So while we're doing this, I do want to highlight that we can, with the two-channel system, actually start to set up our next run if we wanted to. So I can simply slide over to channel 2, start programming my next run. And again, with the latest software, we can actually queue this into the system. So we can actually make sure that the system is up and running basically 24 hours if we really wanted to. So we don't have to have any sort of wait time for the next sample to happen. So we can queue this next run, and it'll prompt us to load the sample when the system is ready. So you can walk away, have a nice coffee. And I think one thing that I like about this remote software is that I can kind of look at my data from wherever I'm at. I only work about 15 to 20 meters or 20 yards away for those who live in North America from my computer or from the lab, but I don't like walking back and forth. And obviously, I'm not allowed to have coffee in the lab. So it allows me to look at data, and I can access this from wherever I am, especially if you've networked it and you have an active VPN. I can look at this data if I'm in across seas or across over in California area. So I can access this, especially when I'm working on projects from wherever I am with the Selekt Remote software. So. And as we approach the end of our gradient, we have a nice separation from these 3 peaks. Again, this gradient was designed simply by that TLC information. So if you are doing your chromatography and you do test a bunch of TLCs, you can utilize that to adjust these, adjust these parameters. But it's a great starting point from the system, so you don't have to spend much time optimizing a run to get good chromatography. At the end of our runs, you do get a couple of options. So if you are seeing that your compound may be still coming off at the end, maybe it's having a little bit of tailing, you can always extend that run. We give you that option so that if you have mass that's coming off, we don't want to necessarily sacrifice it. We want to make sure that you can still collect it if you so desire. So we can extend the runs. We have an auto extension feature as well if your compound UV absorption is below threshold. So all of that can also be automated for you. And lastly, again, we want to make sure that your system is up and running. So we have an automated cleanup cycle that is performed at the end of the run. I do have customers that try to skip this. I highly recommend against that. You don't want any sort of compounds or anything left behind in the lines. So we do recommend flushing it at the end. Again, this is all handled for you. And I'm just going to hit that cleanup button, and it'll perform the cleanup. So with that, I do have one more poll question for you guys. And I'm curious what type of chromatography everyone is working on. Are you guys doing normal phase? Are you guys doing reverse phase? So I'll turn it over to Simone for that question.
For our third poll question, please tell us what type of media you're most using in your labs. The answers are in Austin. Our predominant answer is normal phase silica, and each user clicked normal phase silica.
Okay, so some normal phase chromatography going on. The Selekt is designed to be used with reverse phase. We use it in the lab for peptide purifications all the time. Again, another advantage of having the 2-channel system is that you can have them set up one for normal and one for reverse. Or if you have any of the other functionalized medias in that poll, those can be tuned for those types of solvent systems. I definitely recommend if you haven't tried reverse phase, there are some molecules that are quite polar that might benefit from a reverse phase purification. So definitely give it a try. Completely compatible with the system. So great. Thank you, Simone. So with the results in, this is an analysis screen will pop up showing all of our peak information and our fractions that were collected. So here again, it gives us information about what our elution or our strong solvent percentage was once the sample eluted. Gives us the column volumes. You can always switch this around. I know a lot of our customers like to work in milliliters or in time. I always like to work in column volumes because it makes it a little bit easier to think about when you scale. So we can pass over each one of these and it'll highlight the individual vessel that the sample is contained in. We can also look at that 2D spectrum, so we can analyze, again, which compound might be our compound of interest, but also identify local maxima, so where we get the highest sensitivity for our sample. Because we can control the range of our UV range for the runs, this helps us kind of, again, tunes for sensitivity. So instead of utilizing the entire UV spectrum, we can tune it to a wave range that's going to have the most absorption. So this helps especially with compounds that you might think have high UV absorption, but once you put them on the system or when you're using, say, something like ethyl acetate, it kind of mutes some of that UV intensity. So this helps us to narrow it, improve it. We use this all the time for peptides that have a specific range and absorb in a much lower wavelength range. So something to consider when you're using this analysis option. We also have the 3D a 3D spectral analysis as well. So if you guys want to get into a little bit more detail with how your runs are looking and how to optimize it, you can utilize that. And all of these images can be sent to the report. So if you're trying to impress your boss with some very pretty images, you can add those simply by clicking Add to Report. Now, as we scroll down through the report, which is going to record all of the run parameters that we had, what column we used, flow rate, sample mass, those types of things. And it'll also include your nice spectrum for use in your meetings. All of these results can be tagged to make it easier to find results and combine results. So we can tag them with things like project names or usernames. And so that makes it a lot easier to find results once the run is done, or once you're starting to create your presentation or poster when your project is complete. So we do have that as well. In the analysis window and the results window, we can also create runs from previous results, like I said. But what I haven't shown is our gradient optimization feature. So if you want to spend less time in front of the instrument, but you have maybe a tricky purification, we can perform gradient optimization. And this allows us to identify a peak of interest, and the system will automatically create a gradient for you that is designed to be faster and utilize less solvent. So again, really great for if you're doing any sort of scaling optimization. We can select our different peaks of interest, and you can see over here how our gradient might change. So it went from a single isocratic gradient to something with more of a step, and further change it to a higher percentage for later eluting compounds. We can change the threshold here to be more selective with which part of the peaks that we're most interested in if you were worried about anything in the shoulders. And if my peaks weren't baseline resolved, I could reduce peak sensitivity again for kind of capturing or not capturing shoulders. Unfortunately, they're baseline resolved here. And then we can apply that gradient and immediately create a run that is designed, again, to use less solvent and be quicker. How are we doing? So with that, that is kind of a quick overview of the Biotage Selekt software and actually how to utilize our columns and how to do a run. So with that, I'll ask our final poll question. Of the features I've maybe highlighted today or some that I didn't, which one would be the best or greatest impact on your workflow? So I'll turn it back over to Simone.
Please tell us which capability would have the greatest impact on your purification workflow. This will be our last poll question before we focus on questions from our viewers. I'll wait a couple more seconds. All right, Austin, I think we're ready to share the results. Our most popular answer by 100% was automated TLC to gradient or method optimization tools.
Awesome, yeah. Something that I wish I had in grad school, absolutely. Learning chromatography as a bench chemist is definitely not something that's that easy to grasp when you're first starting out. But that TLC to gradient feature definitely saves time in creating those gradients. We do kind of have a standard gradient format from that algorithm. We do try to elute those compounds in about 10 column volumes. But yes, absolutely, using that TLC to gradient feature is one of my favorites. With that, I'll open the floor up to any questions from the audience. Happy to answer anything you guys have questions about.
Our first question is, can I reuse the columns?
Great question. Typically, our columns are designed for single use. There's a lot of reasons for that. Minimizing cross-contamination, minimizing any sort of compounds that maybe you didn't see actually elute that are still stuck in there, and then compromising your second purification. Albeit my customers sometimes listen to me, they sometimes don't. So they are able to be used a couple of times in a row. I typically max out about 10 before you actually probably are losing a good bit of chromatographic performance from the column. So from run 1 to run 2, you'll probably see chromatographic resolution drop. So that's why I typically say use the column once and use the next one. But up to you guys to determine what's useful for you guys and what's not, because I know that is something I get asked a lot.
Thanks for elaborating on reusing our columns, Austin. Our next question is, can you talk more about how to load samples that are poorly soluble in the desired eluent? For example, loading as a slurry or loading pre-absorbed on silica?
Sure. So slurry loading is probably not your best option. I would definitely recommend dry loading, like I spoke about earlier. This helps again to minimize the solvent effects of your sample. Like I mentioned before, utilizing those duo columns allows you to do slurry loading, or allows you to do other loading options. For dry loading, again, we're mixing our compound with the silica or the media that we're trying to absorb our compound on, removing that solvent, and either loading that directly on top of the column frit, or utilizing the samplet and or DLV to perform that dry loading. So what that's going to do is ideally improve resolution, because the solvent that you're using is eliminated, but those polar solvents are going to drag your compound onto the column quicker than if you're using a weaker starting solvent, especially if your conditions have a low strength to begin with. So you're going to see a lot of resolution loss from that. But it also so with those capabilities, because we're able to get sometimes a thinner band, you're going to have less band broadening, and again, going to give you better resolution from that. So both are possible. I hope that answered that question, but feel free to ask it maybe in a different way.
Thanks for sharing insight on loading capabilities. Our next question is kind of more of a troubleshooting vibe.
Perfect.
Our viewer is asking, sometimes when I press play and equilibrate the column before loading my sample, the silica still seems to have dry spots and is not fully wet all the way through. Is this a problem? Do I need to equilibrate it longer or with more solvent before loading my sample?
If you're seeing that, I would definitely check the flow parameters that you're setting it up with. Again, we typically equilibrate with higher flow rates and pressures. But ideally, if you're equilibrating the column, depending on where you're seeing those dry spots, I've seen some that are at the bottom towards the column, which just means that the column needs to be wetted further. So as long as the majority of the column is equilibrated and wetted before loading your sample, it should be fine. So if you are seeing that, though, feel free to reach out to Simone or I. Maybe we can kind of troubleshoot that a little bit more.
Thanks, Austin. Our next question is, how much time can an automated flash system realistically save compared to running manual columns?
Days. I used to run manual columns in grad school, and it would take me, I got pretty good at it. It would take me about an hour for setup. But it's really standing there and waiting for those fractions to come off the system, adjusting the flow rate based on your positive pressure that you're using. And so the automation aspect of this is I get to load my sample and walk away. And so that frees me up to do my next reaction. It frees me up to maybe evaporate down my last purification run and get ready for whatever else I have going on today. So the biggest thing about automation is it's going to allow you to be more hands-free and still get the purification that you want. So.
Thanks for providing insight on how automation helps labs. Your next question from our viewer is, we have experienced chemists and new users sharing the same system. What are the best practices for ensuring consistent results across different operators?
Yeah, so one feature of the system is, again, you have that user lockout capability if that's something that your lab wants. So that way, any users that are more advanced and they want to keep their results and methods separate from newer users, you can have that set up on the system. But I will say the Selekt system is designed to be very user friendly. So ideally, a new chemist is able to do similar things as an advanced chemist. Obviously, the advanced chemists are probably going to take advantage of more of the customization features that we have. But again, it's designed to make sure we're not having any sort of cross-contamination by cleaning out the system in an automated fashion. But it's also allowing those users to have their own methods, lock those methods so that no one else can change them. So there are some controls with some of our newer software features and newer packages that allow that kind of crosstalk to happen, but not in a way that's going to be detrimental to the purifications.
Thanks, Austin. Our next question is, for labs currently using manual flash or older automated systems, where do users typically see the biggest time savings?
Yeah, so again, coming from manual to automation, you're saving time not being in front of your column collecting those fractions by hand. For older systems, we can actually run at a lot higher flow rates and have a lot wider range of columns available for the Selekt system. So higher pressure, higher operation perspective from that. And again, some of the features on our newer system allow for greater automation. So again, one of my favorites is that remote software that allows me to access the system without being in the lab. So I kind of monitor those reactions. Some of the older, chromatography, some of the older systems don't have that capability. So it allows you to, again, be more hands-free and allow the system to do all of the work while you're off, again, doing other things. So.
Our next viewer question is a little broad, so I think they kind of want you to
Okay.
elaborate more.
All right.
They're asking, can you talk a bit more about the ELSD?
Sure. So again, the ELSD is an evaporative light scattering detector. It's supposed to be more universal. So I typically use this for things that have no UV absorbance or very limited UV absorbance. So things like sugars, things like fatty acids that maybe have carbonyls, but they're not really strongly absorbing carbonyls. And so I utilize it for that purpose. So the way that it operates is as your sample is flowing through the column, it then gets routed through the ELSD or sampled through the ELSD. We do have one of the smallest sampling rates. It is a destructive technique, so we do have the smallest sampling rate on the market. So that's intended to not use your sample, but still give you that information that we're seeing either something's coming through the system or not. It does have an auto scaling feature. Some of our older ELSD unit, you had to make sure that the sample concentration coming through was within a certain window. Now that's fully automated by the ELSD unit, so you can make sure that you're seeing very dilute compounds or very concentrated compounds on the same scale. So as it goes through there, it's going to get vaporized into very small particles. Those particles are going to be dried, and then those particles are what is actually scattering the light from the detector. And we see that detection, we can see the sample. So all of that's handled automatically. The ELSD unit also, as with the main Selekt unit, self-cleans. So that also gives it a very low maintenance interaction between the user for that as well. So something different from our older systems. So hopefully that was a little bit better elaboration. Feel free to fire me more specific questions on that if you have more questions.
Our next question, I'm going to quickly answer before we get into the next question for Austin. One of our viewers says, this webinar is great. Is it possible to have a recording of it? Yes, you will be sent the recording. Okay, on to your next question, Austin.
Thank you, Spud.
Of course. Who doesn't like rolling in compliments? The next question is, can you show how to add an unusual solvent to the system? One that's not available from the default list of elements, and how
Sure.
to estimate the solvent strength.
Ooh. Solvent strength estimation, I think, is going to be a little bit more based on literature values. But anytime I want to add a new solvent, I'm just going to move over to the remote software again. Click menu, go to data admin, log in with whatever user information you're using. Go to solvents, and this is where we can add new solvent information. So Austin's solvent. And then again, strength is going to be really dependent on a couple of different factors. I guess the best way to kind of look at that is to compare it to other solvents. So, common systems are going to be ethyl acetate, hexanes, or maybe something like MTB and hexane or heptane. Those are kind of where I start, at least for normal phase. MTB is a little bit weaker. Ethyl acetate, is kind of a universal in that sense, and play around to kind of identify the strength factor if you can't find it in the literature. And then there is a max aspiration rate. So if you're using things that have a little bit higher viscosity and you don't want any sort of misdraws happening, I typically don't use this. So simply say add the solvent, and now it should be selectable as a solvent on your system. So if I want to add that to whatever my 4 solvents are, I can go to solvent setup, and I can select Austin solvent here, and then swap that out on the actual interface. And it will prompt you if you haven't set that up correctly. So hopefully that answers that question. Sorry I don't have more on the solvent strength aspect of that. Sometimes doing a direct comparison via TLC is your best bet. So great question.
Thanks for that answer, Austin. I'm sure they found it quite helpful. Your next question is, are there regular software updates for the instrument? And if our system is not possibly to be connected to a network, how can we do these updates?
Yeah, so software updates can be added via a USB. I don't think we do those by network anyway. So you can get that software either from your service engineer or contacting our one point support team. But yes, we're making regular updates, especially as we add new features, new capabilities, and if you guys are experiencing bugs, we try to fix those as soon as possible. So, but those are simply added via USB. So you don't need a network connection for that.
Your next question is, how does wavelength scanning help improve fraction collection or compound recovery?
Great question. So as I kind of mentioned earlier, because we can look at a bunch of different wavelengths all at the same time, that way we're not going to miss a molecule. So if we, I see a lot of literature values that are reported for different compounds, and sometimes they're all over the place. So I never really know where my compound is going to absorb. So by scanning all of those wavelengths, in that analysis portion, you get to see where our compound is absorbing at its maxima. So we can tune it in that sense. And so you won't miss anything. Those are all added up together to give you the signal output that you see. We can also, again, utilize that by shrinking that wavelength to get more sensitivity from our molecule, especially if we have maybe some background interference from our solvents.
Our next viewer would like to know, can I use the same system for both small molecule normal phase work and reverse phase peptide purification without extensive reconfiguration? How difficult is it to switch between normal and reverse phase purification?
Absolutely. Great question. So this lab here is designed to, in the Charlotte office, we do both peptide work, a larger molecule work, and small molecule work here. So if the system has been configured with these lines that have reverse phase solvents, all you would have to do is switch to your second channel, take control back, switch to one channel, set up your solvent setup appropriately. So I would change my Austin solvent and dichloromethane to maybe methanol and water, or acetonitrile water. And then I would choose those on this options and then hit play. And it's going to go ahead and flush the solvent lines and the system lines with the strong solvent from our normal phase run. It's then going to wash it with the strong solvent from our reverse phase run. And then it's going to wash automatically with the starting conditions of your reverse phase run. So it is ready to go for that next solvent system. If you did have to switch over the solvents on top to that reverse phase, basically simply take your lines out of the solvent bottles, prime them, which is going to dry out the lines. If I am switching from a reverse phase solvent to a reverse phase solvent from a normal phase solvent, I may do a methanol wash in between there just to make it a little bit, get rid of any sort of residual nonpolar solvents. So prime those lines, maybe do a single wash with a polar organic, and then put it into my next solvent and prime that as well. And so it's very easy to switch the solvents on the system if you are switching it to normal to reverse phase, if you don't have those solvents on there already. But if you already have them on there, it's as easy as just switching to the channel that you have set up for the reverse phase, and it'll do those washes for you.
Your next question is, what loading strategy do you recommend for crude peptides dissolved in DMSO? Do you have any tips?
Oh, loading strategies. I can answer that a couple of different ways. Typically, I mean, the biggest thing is making it as concentrated as possible. Peptides are truly difficult just because you don't really know what they're going to be soluble in. So using DMSO is a pretty good catch-all. We typically recommend, and I can't remember off the top of my head, actually, Simone, you probably have a better answer for this. But again, most concentrated as you can, and I think no more than, is it 1 to 2%, Simone, peptides?
3% or less.
3% of the column volume of the system. So we try to stay below that from a DMSO volume capacity perspective. I also, personally, I like to use methanol. It's a fairly weak solvent compared to acetonitrile, and you don't get a huge UV peak at the front of the purification. But it will depend on what kind of resolution you're seeing. DMSO is going to give you the best resolution between peaks because it is more polar compared to something like methanol. So hopefully that answers your question.
Thanks,
I have
Austin.
tried dry loading. I have tried dry loading once. I kind of want to play around with that a little bit more to see if that's something that's that I can at least make work. So, in theory, it should.
Thanks for your answer, Austin.
No
The
problem.
next viewer would like to know, how do you decide between Bio C18 and Bio C4 columns for peptide purification?
Sure. I mean, that's going to be based on your retention. If you have something that at 100% acetonitrile is staying on a C18 column, it's probably best to switch to a C4 column in that aspect. So C4 is shorter carbon chain, so it's going to hold on to hydrophobic compounds less. So if you can't get it off C18, probably switch to C4.
Thanks for providing insight. Your next question is, for medicinal chemistry workflows, what sample loading level do you typically recommend relative to column size?
Sure, great question. So like I was saying earlier, I like to start at a 1% load. This is, again, going to minimize the amount of sample you're using, and typically you're doing this on a small column. So again, really minute sample size, and optimize at that scale. The columns can go up, especially normal phase columns can go up to a 10% load, just by kind of specs perspective. But that's really going to depend on the chromatography and the separation that you're going to get. So I always start at 1% load and then work my way up. If I have great resolution or greater than 2 column volume resolutions, I can definitely push that to 5 to 6% pretty easily. But yeah, and I also, I'll start with our irregular media columns as well, because those, save on cost. So start there, get through some of your purifications, and then you can, when you're ready to do that final purification or scale up, switch to our high capacity media, and you'll see a great improvement in resolution. So that's traditionally how I do my workflows.
Thanks, Austin. Your next question is, how reliable is the TLC to gradient tool for compounds that streak or show broad spots on TLC?
Great question. So a TLC to gradient is taking your kind of, I want to call it an absolute spot, but basically it's RF point at its most traveled distance, essentially. So if you see something streaking, you're likely still going to see it streaking on your column. So that's probably more indicative that your compound needs to have either some sort of ionization normalization, so adding a modifier, or I see it typically with amines on normal silica. They have a lot more hydrogen bonding, so they tend to streak on the column. So in that case, I would likely switch to an amine functionalized media, or again, add that modifier that's going to help with streaking. So the TLC gradient should still give you a bit of information where it's going to come out on the column, but it's not going to prevent your streaking from that you might see on the TLC.
Thanks for elaborating on that. I'm sure our viewers found that helpful. Our last question from our audience is, how does the Selekt perform with compounds that have weak UV absorbance, such as saturated heterocycles or linker intermediates?
Yeah, so again, And depending on if they have any UV absorption, you should be able to see where that absorbs based on the spectra analysis. But that is why we have the ELSD module as an option, because typically you are not able to see those, especially using the gradient with ethyl acetate hexanes. So again, I definitely recommend utilizing the ELSD in those cases, but it is able to handle that just fine.
Well, thank you, Austin. I'm sure the webinar was wonderful. You've received so many compliments during this session. Robin, I think we're ready for you.
Okay. Thank you, Austin. Thank you, Simone, for this great demonstration. We really appreciate all your hard work. Thank you all for taking time out of your busy schedule to join us today. We appreciate your participation and hope you found the session valuable. If you have any additional questions or would like more information about the Selekt system or to talk with one of our specialists, please don't hesitate to reach out to us. And I'd like to say have a great day and thank you for joining Biotage.
Thanks, everyone.
Bye, everyone.